Hello and welcome to day two. If you haven't watched day one and you don't know what's going on, I'm taking a creative engineering class taught by Mark Rober, and I'm making some videos as I go just to document what I'm doing, and hopefully this will lead me into a more effective design process so I can make more projects in the future. So day two, we are working on writing out the requirements for our build. If you're not familiar, I'm hopefully building a machine to sort out M&Ms, Reese's Pieces, and Skittles. And then after that, we evaluate some design options in order to see which options are going to are possible in order to accomplish our goal. And then third, today we're doing experimentation. So this will help us eliminate bad design options or potentially come up with some uh, ideas that could potentially lead to a functioning prototype. So let's get started. Okay, so requirements. We're going to have essential and non-essential. So essential and non-essential. And yes, my handwriting is atrocious. Okay, essential and non-essential. So essential is sorting candy into let's say cups, but whatever receptacle is appropriate is fine. Non-essential would be something like taking a whole bunch at once. It would be kind of lame if I just dropped in one at a time. But if that's what it needs in order to be successful, then so be it. That's a sacrifice I'm willing to make in order to have a successful machine in the end. So I'm going to say non-essential is loading multiple candy, because I see like if so in Mark Rober's video he's doing something with candy as well, and he's dealing with things like a hopper and how to get all the candy to go in and stuff like that. And with my machine it would be sort of similar, where it would take a handful of candy and like so I've been watching not Mark Roberts. I've been watching Wintergotten on YouTube, where the guy's building a new marble machine to play music, and he recently pretty much gave up on the machine that he'd spent the last several years building because it was too fragile. Like it wasn't functioning the way that it wasn't functioning to a level that he needed. And if you looked at his design, the place where he was having pitfalls were, one, where it split the marbles from one lane into multiple, and two, where it took marbles from multiple lanes and brought them into one. And that guy's been doing this professionally for years, using marbles with very high tolerances, or well, low tolerances. There's very little difference between the marbles, and these issues have been stymieing him for years. So having seen that, and having candy, which has much higher tolerances, although still very good, but there's variation in candy size. The idea of being able to properly handle a you know a number of them and expect them to act predictably, I think is folly. So I'm going to go with loading multiple candy as a non-essential. Um, uh, I would like to have it load a hand or load like a couple candy as essential though. So if it could take like 5 and sort those out, uh, I think that would probably be like minimum viable product. So essential is going to be like a certain amount of accuracy. So I would say like if in each cup it's 75% accurate, especially between Skittles and non-Skittles, I would call that a win. Sorting M&Ms and Reese's Pieces, I was looking at those, and I'm gonna go buy some calipers, but the difference in M&Ms and Reese's Pieces in terms of diameter and weight, and like you can hold two of them in your hand and stare at them, and if you don't see that M, they are nearly indistinguishable. So uh, I might have to uh, to give myself some leeway there. Another non-essential thing that you might find surprising is that uh, M&M's, Skittles, and Reese's Pieces are all so uh, similar, and that is just really I put myself in a difficult position with that one. And fact is that if I have to switch to gumballs and gobstoppers in order to be successful, I'm going to do it. Those are those have much more variation in size. Those are rounder and more consistent. And so if that's what I've got to do, that's what I'm going to do. So I'm really going to try for M&Ms and Reese's Pieces, but if I need to change up my candy in order to be successful, so be it. And yeah, that does kind of ruin the story, but uh, it's a pretty damn difficult thing to do. So candy choices are non-essential. Essential, candy must remain intact. Um, so the I did a couple experiments, which I'll show you in a little bit. And one thing that I noticed was that under certain stresses in the right ways, the candy would just crumble. And as much as much as it would simplify things to be able to just like brutally chop up the candy, it isn't really going to work. So we're going to have to pass on that one. Let's see. I'm going to need a minute to think about other essentials. Okay, well, yeah. Similar to candy must remain intact. Certain requirements by the nature of the product being purely mechanical. No optical. Like, you know, there is slight variation. Like if you look at the orange Skittle and the orange M&M and the orange Reese's Piece, there you can look at them and like if I wanted to use an optical sensor, I could differentiate them in a tenth of a second and just it would automatically sort them all out, and that would be cool. Similarly, no chemical. That's along with the lines of the candy must remain intact. By no chemical, I really mean you can't taste test it. So there's nothing you can do that would alter the candy as tasting would. So no optical, no chemical. So beyond that, I think that anything is fair game as long as it is mechanical. Let's see. So essential, non-essential. Yeah, I think that's about it. I'm going to start drawing up my design options for each of them. Sorry, I forgot to record. The most important thing, the critical aspect of this is sorting candy. I actually had this as two on this thing, essential sorting candy into cups. This is two separate things. Sorting candy into cups. So, sorting candy. We're going to talk about some design options. So, the most obvious one is the different size holes, right? So this is, I'm going to call it the sieve. and there are different incarnations of this. There's the passive sieve. That's where you have like a slope, and there are different size holes, and the holes get bigger as you go down. And with the smaller holes, hopefully the Skittles will fall through there. Hold on, I got a bag of it says M&Ms and Skittles and Reese's Pieces in there. You can see they're all very similar in size. So it would start with the smallest holes, which are for the Skittles. Really, really small difference between the diameter of a Skittle, a Reese's Piece, and an M&M. But passive would be slope. Okay, and then active. Now, the benefit of the active one is that you could make the Skittles pass over more holes as they're going in, so there's less chance of a false positive. The way that I was imagining that would be a tube with baffles. So with this idea, there would be a tube with obstructions in the tube blocking the passage of about half the Skittles. So, like, as it rotates, the Skittles would be able to go down, but also it's rotating, and so it's forcing more candy to move along the surface of the tube as it's going, because not only is it going down the slope, but it's also going around. So a tube with baffles, and there would still be holes in the side of the tube and different collection bins depending on where out of the tube the candy fell. The sieve would have the, sorry, I guess I've messed up my indentation here, but there's passive and active. So the slope and the tube with baffles. What else do I have? So, one thing I was looking at was the contour of these. So if you look at a M&M versus a Skittle, you'll see that the Skittle is way fatter. And if you look at an M&M versus a Reese's Piece, the Reese's Piece well, I don't know. We'll know once I get a caliper, but it looks like the Reese's Piece is just a little bit fatter than the M&M, but a little bit skinnier than the Skittle. And so one thing that I was thinking with that was a sort of like a cup system, like if sort of like the sieve option here, except if you have like a slope with cups of some kind, the more contoured candy would sort of settle deeper into the cups than the flatter M&M. And so what would happen is if you have like this sort of slope covered in not really cups but sort of dips and divots, as the angle of the slope increases, the flatter candy will slide down while the more contoured candy will remain. And so the idea with this is that you would, like, if this was the surface, you would have all the candy start out up here, and as the candy tilts up, of course, in this situation, the rounder candy is going to roll first, which also might work. And actually, yeah, you are seeing that the candy moves at different rates, and so as the slope pulls up, different buckets could be revealed for the candy to fall into. And actually, that served as a small experiment that actually yielded some pretty different and surprising results. So I'm gonna have to say like slope with divots. And similarly, rolling. I didn't even I didn't even think of that until just now, but I'll be damned if the Skittles didn't roll much better than the M&Ms and Reese's Pieces. Okay, so that's 4 options. One other thing I was thinking of, actually, some of you may have seen Mark Rober's liquid sand hot tub. When I saw that, I actually built one for my kids. Insert video right here. And when I built that, so when Mark did his video, he used mini glass beads for it, and those are very homogeneous in size. There's no dust, there's no big ones or anything. I used play sand, which was a bit of a mistake, first of all, because when you buy it, it comes in a bag that is wet, like there's water in there, and wet sand doesn't behave the same way as dry sand. It doesn't liquefy when air is passed through it. So I just had to run air through it for like 8 hours before it actually dried out enough to use. But the other thing about it is that there's a lot of dust in play sand, and when I say dust, I don't mean like dust in your house. I mean like dustified silicon sand, which is much worse for your lungs and not good for you. Gosh, look at the way that rolls. That's really something. The M&Ms and Reese's Pieces don't do that. That's really positive right there. But yeah, so what ended up happening is that the play sand sort of stratified, where on the bottom layer it was very thick like peppercorns, and then as you got up it was more like sand, and then the top layer is just dust, and when you turn on the air compressor and the sand starts to bubble, it's just like a constant cloud of sand dust, and frankly I stopped feeling like my kids were safe playing with it, so they haven't played with it for a while. But I don't know much about the density of these candies. It's probably very similar because everything about them is similar. But I would guess if there's any variation at all, if I put them in a tube and elevated them with the air compressor, over time, I would be willing to bet that they would settle out and sort themselves pretty effectively. So I'm going to say liquid candy. Liquid, I know how to write liquid candy using air to sort of liquefy them. So that's another option. Another thing I was thinking of, I'm actually going to grab something to show this, but one thing that they talked about in the Wintergarten videos is over-rotation of marbles. And the way that they do that is that instead of holding the marble at the bottom, as you know, if you're going to roll a marble, you might think that it just rolls along the bottom. Instead of that, they would roll it along the edge. And what that does is it takes a lot of the motion that would build up in terms of kinetic motion, that or like a linear motion where it's moving forward. Instead, that would sort of build up as rotation, and then friction would quickly take out that rotation. And so it was a very good way to sort of control the speed. One thing that might work well with this candy, especially where there's the most significant variation that I'm seeing with them is in their thickness. I'm wondering whether setting up a system where it's like two glass panes that converge in a very acute V, dropping the candy in there, whether they might roll down the slope. So I'm going to see if that would work. So I'm going to call that one over rotation. So similar to the sieve method and similar to the over rotation method, instead of having holes where, the nice thing about a hole is that it doesn't matter the orientation of the candy. If it goes through like this or like this, given that it's round, it's always going, like there's no way to have it go through that is narrower than its widest point. You know, it's always going to have to go through in a way that has its diameter going through the hole. However, if I could come up with a way to orient the candy so that like, let's say I have all of the candy falling into the bottom of its container, and then there are two rods right on the bottom. What I could do is I could ever so slowly move the rods apart. and when they get it to a certain width, that means only the M&Ms can fall through, and so then it'll get a little bit wider, and then only the Reese's Pieces can fall through, and then the Skittles will be left. So that could be uh, uh, a possible way to do it. So it's sort of like the sieve, this would be a widening gap. So I did a little bit of research as well. I looked into how I'm going to just sort of write notes over here about other options that I looked at. So when you I was Googling how like old vintage gumball machines, like have you ever like gone to use a gumball machine and it's just like an old like piece of shit gumball machine, and you put your quarter in and you crank it, and then it comes back and you realize it was a Canadian quarter and the machine rejected it. So I looked into how the machines do that. They look at weight. Um, that's something that I'm going to consider. More modern ones use like everything from like electromagnets and optical sensors, which I'm not going to bother with. But with weight, if I came up with some sort of like scale or something like that that could accurately measure the difference. I mean, I can't feel a difference, but I'm going to have to put these on a scale to really tell. If I could measure them by weight, that might be a way to accept or reject or otherwise categorize them. But those gumball machines are lucky in that they have tolerances. Like, you know, there's not much variation in the size or dimensions or weight of a Canadian or American quarter, whereas there's probably significantly more variation in a Skittle or M&M. So I'm going to have to look into that as well. But yes, these are my sorting candy design options. Wow, look at the way those roll. That's really something. I'm gonna have to definitely look into rolling, because you know, just wiggling it around, it's pretty easy to get the Skittles to separate themselves. So that is looking more and more like an option. Okay, let's look at some of our other design options, and I'm just using the 8x12 paper because I don't have anything else. So load a couple. So we could talk about a hopper. Accuracy, that kind of ties in with the sorting. The cups, it's like that's just like, you know, whatever. I'm really not super concerned about that. The candy must remain intact is something that I'm going to have to evaluate different materials for. So I'm going to just say intact candy here. Okay, so for intact candy, I'm going to need to evaluate some different materials. So, like cardboard, I think one of the big issues that I'm going to face here is cardboard. Is that things need to not only be gentle on the candy, but things need to be accurate. And I don't think there's much. There aren't many mechanical creations that you can make out of cardboard that will last more than a day running nonstop. They'll, you know, especially if they're doing something like sorting a heavy candy, like even just dropping a candy like that on a piece of cardboard over and over again will cause it to deform. And so I'm not super into the thought of trying cardboard all that much. Same goes for paper. Really, any sort of product that turns to mush over time. I do want to try both softwood and hardwood. Softwood is easier to work with, but I don't think it will maintain its tolerances as well. Hardwood, I think I can get like a more accurate cut with it and make things that will sort candy better. Metal, so one thing that I'm considering is that, so I did some Googling on the size of an M&M, and an M&M is 1.04 centimeters in diameter. And what that means is that if I can find washers that, or really anything that has an inner diameter of 1 centimeter, see, this is why I need to buy calipers. I think that will be less than the diameter of a, or that will be more than the diameter of a Skittle, but less than the diameter of an M&M. And so, um, so that seems like a tangible thing. So I need to go to the hardware store. I'm going to go to the hardware store with a pocket full of candy, and I'm just going to be going around seeing what I can what I can fit a Skittle through, but I can't fit an M&M through. And actually, yeah, here, look at this. I'm just noticing this right now. This is also an M&M, and you can see it's got a giant divot in it. Or sorry, this is a Skittle. It's got a giant divot in it, and the way that it behaves versus the way that the yellow M&M behaves, it's like a completely different candy. And you can see the yellow one's also got an imperfection as well. So that is definitely a complication. The gumballs and gobstoppers is looking more and more like a possible option the more I look at these. But whoa, throwing candy. Okay, and along with metal is plastic. Both metal and plastic, these are, you know, like if you go to Lowe's and you get a washer with a 1 centimeter inner diameter, they're all going to be very close to that. Most hardware that you get is, you know, done very accurately. So metal and plastic, I'm going to see if I can find something that very closely matches my needs. And that's going to be useful for pretty much anything where I am doing some comparisons between the two. So I am most in favor of these three. So we're going to see what I can do with those and what sort of results I can get. Okay, and so I'm just going to do some design options for the non-essential. So loading multiple candy. So what I would like to have for loading multiple candy, or loading a couple candy, either way. I'm just going to put loading candy here. So Mark, in his video, he also has a candy loader. He uses a tube, which is kind of nice, although whereas his has sort of like a dispenser at the bottom. I don't even know what I'm going to do there. So what I'm thinking more is a funnel, and just throw in like a tablespoon of candy at a time, like 5 or 6, and hope they get sorted out. We'll have to see how that goes. So then lastly, we have candy choices. So yeah, I'm definitely doing this in hard mode with my choices of candy right now. These three are very difficult to tell apart, even when you can look at them up close. I mean, the Skittle is by far the most identifiable, but like if I grab, this is a brown M&M and a orange Reese's Piece. If I grab a orange M&M, I'm not even sure if I'll be able to find one. Let's see. They do make orange M&Ms, right? Where is an orange M&M? Hey, there's an orange M&M. And a brown Reese's Piece. Let's see if I can find one of those. Yeah, like this is where having an optical sensor would be super handy, because the visual differences are most significant in color, but if you can't see those M's there, it is damn difficult to tell those apart. This is what I'm going to need calipers for, because like this M&M looks the same size as these two, but smaller than this one. Like this one definitely looks bigger. I don't know whether that's subjective or whether that's actually the case, and so some calipers will help me figure out whether that is something that I can actually measure by. Sorry, you didn't actually catch me writing down some candy choices here. So I'm going to write down gumballs and gobstoppers. I'm also going to write down other M&Ms. It would be cool if I could stick with the original description and maybe try some other M&Ms. So that will be like the peanut M&Ms or the caramel ones, which are thicker, or like the peanut ones are huge and can have some significant variation in their size, but also the peanut butter M&Ms. So I'll get a couple of those. That might give me a little more freedom with, being able to distinguish one from the other, and maybe it will affect my final design. So I'll see where I get with my other design options, and if it seems like my given goal is impossible, then I'll move to more tangible options. All right. So I've got my first design option here, and I don't think this is one that, or my first experiment here. This is for the over rotation design option, and I really don't think this one is going to work. But what I've done is I've taken two glass panes and I've taped them together at the bottom, and then I've taped them together again at the top with a gap there to create sort of this very narrow V. And so what I'm going to do is I'm going to drop some candy in there and see, well, first I want to make sure that it sort of goes to, I want to see if it goes to various depths. So there's some M&Ms. I'm going to drop a Skittle and see how, here, let me make it more visible. So the Skittle went to a much higher depth, and then the M&Ms and then the Reese's Pieces were at the bottom. This is another Reese's Piece, so hopefully when I drop this one in here, it'll go further down than those M&Ms, and it does. So that creates sort of like a without a caliper, this is the best depiction I've got in terms of the thickness of them. It would seem that this Reese's Piece and this M&M are of pretty much the exact same thickness. So that means that using that to separate those isn't much of an option, but it does look promising for the Skittle and Skittle separation from the others. So I'm just going to grab a handful more of these and drop them right in. And actually, that was kind of doing what I hoped it would do. So here we've got a couple of things happening. Those are all Skittles at the top and all M&Ms and Reese's Pieces at the bottom. That's kind of cool, the way that they separate out like that. Now the question is, if I angle this, are these going to rotate out? Because if I could, let's see, that one is rotating, but this is really something that works better with perfectly spherical things on a two-rail track, not so much these super narrow pieces of glass. But yeah, these do not come out. Well, yeah, but it is interesting. We do get that stratification there, which is somewhat promising. That is all M&Ms and Reese's Pieces below, and those are 3 Skittles on top. So, worst case scenario, if I go with this design, drop them in, stick in something like vaudeville hook, pull out the Skittles, and then open up the bottom, M&Ms fall out, and I've got something that'll separate those for me. So that's kind of promising. I did this first because I was hoping to eliminate it, but really having this very distinct stratification here it's really really something else. Look, so we got another, like, all rows of Skittles. The only M&M that we have there is stuck because it. Oh wait, hold on. No, that's a Skittle too. Yeah, it's still stratified. I think I saw an M&M that got stuck, but then fell below. But yeah, those lines are really kind of impressive. Oh, is that a Skittle that fell? No, that's an M&M too. Yeah. So no joy on determining Reese's Pieces versus uh, M&M, but this does look pretty cool. So very pleasant result there. Okay, next I'm going to be doing some weight measurement on these to determine whether or not I can differentiate these by their weight. I'm not the best engineer. I'm not even a good engineer. I have no engineering training, at least none formally, and so I don't really know whether I have the ability to make something precise enough to really differentiate two candies by weight. But let's just see um, how much they weigh. Let's see. So if I turn this like this, the camera can see it. All right, so I've got this zeroed out, and I'm guessing that it's not even going to register. And I was right. This scale is much better for measuring ounces or, like, many grams than it is one. I use this scale for making soap. 10. All right. So let's start with the big kahunas, the Skittles. This isn't. I'm noticing a lot of imperfection with the Skittles. See, this one has a divot in it as well. All right, so scales on, zeroed out. All right, so 10 Skittles is, well, let's see. That means a Skittle is 0.042 grams, approximately. I'm just going to write it right here. Okay. Yeah, and it varies a little bit. Like if I push down, looks like, yeah, 0.041. Yeah, I need a dither to shake the scale. All right, 0.042. Okay. So now let's weigh 10 of the Reese's Pieces. I really hope it's not 0.042. Hey, look at that, 0.27. Reese's Pieces are 0.027. So that is like 9/14. 9/14 the weight of a Skittle. That's a much more significant difference than I thought it would be. So that's pretty exciting. And yes, I know that says 0.27. The reason why I'm saying 0.027 is because there are 10 of them. Okay, next, let's weigh the M&Ms. If these are smack dab in the middle, I'll be somewhat pleased. But I still don't think I have the skill to really differentiate a 200 or 0.15 grams. Yeah, 0.29. So an M&M equals 0.029. So really, if I was going to differentiate M&Ms and Reese's Pieces, I would need to build a machine that was sensitive enough down to 0.002 of a gram. That's just not really feasible. So that pretty much nixes the weight option. Even differentiating a Reese's Piece from a Skittle, which is the most significant difference, that's still measuring 0.0. That's a you know, 2/100ths of a gram. It's not a differentiation I can really, you know, 2/200ths of a gram rounding up. So rounding down, that's still 1/100th of a gram. I just don't have the confidence or the time or energy to build something with that amount of precision. If I made like a really long lever, I might be able to do that, but that's just not something I can muster. So that eliminates weight as a differentiation option. Okay, so I've crossed off weight, I've crossed off electromagnets and optical sensors. Over rotation I tested, and I was somewhat pleased with the result. Um, uh, I'm going to probably nix the liquid candy, as much fun as it would be to hook everything up to an air compressor. The air compressor, there's so much variation in pressure and like the way, like if they tumble or bounce off each other, or like the number of the amount of candy in there like weighs down the other candy. And so as cool as it would be to use a Mark Rober liquid sand, except with candy container as my solution to this, I'm going to have to cross out the liquid candy. And so I'm going to start messing with the slope with divots, and also rolling. So I think I'm going to start with actually rolling, because what I'm thinking is both of these could use glass, cardboard, wood, or PVC, and I could evaluate how they do. I'm going to get started on that. Okay, so next I'm going to do some slope measurement, and I don't have a ruler, which I probably should, but instead I'm just going to use Lego notches, because it's not really about how many units, it's about the comparative difference between the different solutions. This is a nice flat piece of, it's pretty much cardboard. It's actually a painting of flour, but you know, it'll do in a pinch. So what I'm going to do is I'm going to take all of my M&Ms and line them up over here. Okay, and then I'm going to put my Skittles in the middle because it rhymes. Then I'm going to put my Reese's Pieces over here. And my goal is to see how many notches up I need to go for each of them to roll down. And what I want to find is the most significant difference in precision between one candy and another. So I wish I had my Lego gears set up, but that's one notch. That's 2 notches. That's 3 notches. That's 4 notches. 5 notches. 6 notches. 7 notches. 8. So this is interesting. This is not what I expected. But the Reese's Pieces have all slid down before any other. But like I expected the Skittles to roll first. But instead we got all of the Reese's Pieces sliding down while the M&Ms held fast. I'm going to have to check that again, switching the Reese's Pieces and M&Ms to make sure that my hand wasn't warping the cardboard too much. But that is really promising, actually. And then all of the Skittles go. Of course, they go every which way. But the M&Ms hold fast, even with an accidental bump of the board. We have one M&M sliding down on that. One Skittle is holding fast. And then the rest all go at once. But that was cool with the Reese's Pieces and M&Ms. That is a significant difference between those two, and I am excited that I found that. So I'm gonna repeat that experiment. I'm gonna do it twice more. I'm gonna just change up the location of the candies just in case this cardboard was warped a little bit. So I'm going to see whether the Skittles last as long over here. So that's 7. Where did the rest of them go? Here's 1. 8, 9. There are 9. I can count 10. All right, there's 10 of those. 1, 2. All right, the Reese's Pieces now go in the middle. Alright, so if this is successful, it's kind of an interesting problem because if they're all mixed together, you're still going to get the ones on top sliding down. So what we're going to need to do is come up with a way that they move and their slope increases. Maybe like a, actually, yeah, if you could have like a conveyor belt that slowly tilts and they get loaded onto that conveyor, then that would just do it like that. So you can't see any of my hand gestures, can you? Well, this will have to do. Yeah, so we got our Reese's Pieces here. We're going to put our M&Ms here. If this is a reproducible result, this will be even more awesome than the glass wedge, because that means a significant difference between M&Ms and Reese's Pieces. So these are all M&Ms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here we go. Here's hoping the Reese's Pieces go first. 1, 2, 3, 4, 5, 6, 7, 8. Oh. They did all go first, and then the with the one Skittle holding on, and then the M&Ms go last. Wow! I would not have expected the biggest difference between Skittles, M&Ms, and Reese's Pieces to be the amount of friction they have, but that is pretty cool. I'm gonna have to think about this. I'm gonna have to do this with other materials to see whether cardboard is the best, because cardboard is pretty high friction. Like if I do glass, there's a lot less friction there. It might be a more significant difference. It might be a less significant difference. So we did M&Ms on the left and right. We're now going to put M&Ms in the middle. Hopefully they'll continue their pattern of being the last to go. We're going to put our Skittles over here and our Reese's Pieces over here. The Skittles aren't even rolling, really. Only really towards the bottom once they've built up some momentum and their kinetic friction outpaces their torque, but or becomes greater than the torque of the kinetic friction is enough to make it overcome its own gravity, holding it back from rotating. So I think that's everything sorted out. We've got 10 and 10 and 10. So let's go and see whether we get the same Reese's Pieces first, Skittles second, M&Ms third. So it'll be a major victory. Uh-oh. Hey, that's good. Okay. Skittles second. And then M&M's third. All right. That is so cool. Oh, that is so exciting. Now to just repeat that with other materials. Good job, flowers. But yeah, I am now imagining a conveyor belt that, like a Mobius strip conveyor belt. It'll go and it'll twist as it goes, and just a little bit of an angle, come back up and just go around like that. That will be awesome if that's all it takes to separate them. Okay, onward. Let's see. I know I have glass somewhere. Alright, here's the same glass I did for the over-rotation experiment. I'm going to use this to test the same properties. And fortunately, this doesn't warp as much as the cardboard, so I'm not anticipating its placement to matter so much. So it shouldn't take as many experiments to determine whether this yields the same results as the tilting cardboard. Okay. Whoa. There's our 10 Skittles. And yeah, I haven't been recording data. Right now I'm just testing out the design options, and if this still seems promising, which it really does seem promising, I'll see if I'll see if I can really quantify some results when I'm done. Okay, so here is glass test. I'm not going to bother notching it up the Lego for now. We're just going to see how it does. Oops, alright, hey now, alright. So, I might need a bigger desk for this one. Okay. Sorry if the camera angle is awful. Alright, here we go. Ready? Tilting up. Skittles look like they're gonna go first on this one. The Reese's Pieces are ready to go next. Yeah, so that's definitely a lot noisier. I guess it helps to have a rougher surface for these to slide down. But still, the M&Ms are the highest friction of them. Okay, so yeah, glass is looking like not an option, which is good, because, glass is hard material to work with, but that's some good data. All right, so I've gotten some pretty good results tonight, and I've got to edit this all and upload it before I go to bed. So I'm going to call it right there, but really good results with these. I'm less worried about needing to get holes that are the exact right size to fit the different candies through. So I'm still going to buy some calipers, see whether that's an option, but the results I got from this this cardboard slope was just phenomenal. Like the huge difference between the Reese's Pieces and the Skittles is like a complete game changer for my optimism on this project. So I'm going to upload this and call it a night, and tune in tomorrow.